Hello and welcome to another LeetCode problem. Today we're going to be doing the problem of the day for July 3rd, and it's buddy strings. So in this problem you're given two strings, s and goal, and return true if you can swap two letters in s such that the result is equal to goal. Otherwise return false. Swapping letters is defined as taking two indices I and j such that I does not equal j and swapping the characters. For example, swapping at 0 and 2 will return, and ABCD will return CBAD. And so they have some examples. So for AB, we need to get BA. Pretty straightforward. We can swap these two characters. So that is true for AB. And this is going to be important to know. Even though they are the same, you are required to do a swap. And so because you're required to do swap, you actually can't do it. And for AA, you can. And so this is, from this example 3 and example 2, you're going to learn something important. So even though they're the same here, you can swap characters. And so we can recognize right away that if two strings are the same, the only way the swap would be true is if there are two characters that are exactly the same in the string, right? So if we have two strings like ACA and ACA, we can just swap them. But if we don't have them, like if we have ABC and ABC, there are no characters to swap. You need to swap two characters that makes the string not change. And so that's one hint, right? If the strings are exactly the same, there need to be two characters to make the string not change. So let's just think of like all the other cases. What happens if there's only one difference, right? So let's say we have AB, B, and ABC. So if there's only one difference, then the count, like if you just count up all of these characters and all these characters, they shouldn't really be the same, right? Because if there's only one difference, you need to make a swap. So you can't make a swap such that these characters are the same, but everything else stays the same. It's not possible. So if there's only one difference, there's no solution, right? If there are no differences, then we just need to make sure that there is a pair of characters, like in this case here, right, that we can swap. And so let's write those. So let's just write for, like, what are the things that if they happen, we can automatically return false. Okay, so if number of differences does not equal 0 or 2, so let's just say or 2, we can return false because for a 1 you can't do it, and for more than 2 you only get one swap. So this is just false. Okay, so that's one case. Now let's get rid of some of this. Now the other, so now we just need to break it down to the 0 and the 2. So if diff equals 0, remember what we said? We said that we need to have two characters that are the same in the string so we can swap them and essentially do nothing, right? Like if we have two characters that are the same, we can just swap them and it'll be the exact same string. If we don't have that, then we can't have a valid solution. And if diff equals 2, you can always have a valid solution provided one thing. So you can have a solution provided the counts of each character in the string are the same, right? So if you just count up, like in a dictionary, if you just count up the counts of the left and the right, if you can make a swap to make them the same, the counts of each character have to be the same, right? So for this A, B, and BA, you would have 1A and 1B, right? Like if you had AC and AB and they had different counts, there's never going to be a way to swap characters. Then similarly for this, AB and AB, you have the same count, and here you have the same count. And so if you have something like this, even though there's only two differences, because you have B, like you need to actually have these C's to swap some stuff, right? And so with two differences, you can do it, provided that like you're always going to be able to do it with two, because you can just swap, but you have to have the same characters, right? So hopefully that makes sense. Okay, so yeah, with two, you simply just swap the two that are wrong. So if the counts of each character are the same, and you have a difference of 2, then it's always going to be like it'll be something like BC and CB and so on. If everything else is the same, this small thing will just need to be swapped to be correct. So that's what we got to do. We got to do this, check the 0, check the 2. And what we're actually going to use is we're going to use what we're going to do is we're going to have a dictionary that stores the letter count of each of these, and then we can instantly use that to say, if the strings aren't the same. Like, one thing to know, if you can't make swaps, if like the lengths of the strings are different, then obviously you can't have a valid solution. And then the same thing is the counts of these characters. The counts of each character has to be the same in both of the strings. Otherwise, like, you can never swap them to be the same, right? The counts of each character have to be the same. So let's actually code that up. So we just need to, like I said, what we're basically going to do is we're going to check this, and we're going to check this. And then anything else has to be false. Because for a 1, you can never have a swap, and for more than 2, you only have 1 swap. So that's just too many. Okay, so let's code that up. So in Python, you can use a counter, but in another language, you can just loop through your string. We are going to be looping through the string regardless. But yeah, so we're going to have a left counter and a right counter. And we do need actually both, because we need to compare to make sure that the number of each character is the same. Okay, so we have a counter S, counter goal. And essentially all this counter is just a hash map of each letter in the left word and the count, and each letter in the right word and the count. And you can argue this is using these as O of 1 because you only have 26 letters. So this dictionary will only have 26 items, which you can argue is O of 1 space. Okay, and so we have that. Now we're going to need our differences. We're going to set that to 0, and we are going to loop through one string and compare different. By the way, so we can exit early if we have some things, right? So if the length S does not equal length goal, we can end early. So we can just end here. Okay, now after we make the counter, we can also end early if left does not equal right, meaning the number of the characters in each one is not the same. So we can return false here. Now we're going to have a difference, and we need to go through the strings and compare characters. So that's pretty straightforward. So for I in range length S, and so if if si does not equal goal I, we are going to update our differences. Okay, so now we have some differences. Now remember our cases. So if diff is 0, what's our case for actually making sure it works? So let's take a look. We need to have 2 characters that are the same in the string so we can swap them. Pretty straightforward. All we're going to do is we're going to check this counter of the left character. We're just going to take the max value, and if that max value is at least 2, then we have a solution. So we can just say return true if max left dot values is greater than or equal to 2, right? Anything greater than 2 works. You can just say greater than 1 if you want. Okay, and then else we return false because that means that we can't swap anything. We need to swap identical characters. So that's that case. Now we need to do the case where if diff equals 2. And so what's our solution there? So for 2, you can have a solution provided the counts of each character in the string are the same, right? So as long as the counts are the same, and we actually checked that here. We checked that here. So the counts are the same, so we can just return true here because we already checked that. And now for anything else, we can just return false because if the difference is not 0 or 2, if it's 1 or anything else, we can't possibly have a solution. So let's try that. Okay. And let's think of the space and time complexity for this one. Finally, it's good to have an easy problem. I would argue it's not super easy, but compared to most easy, but it's good to have an easy problem because they've been doing hard problems for the LeetCode daily challenges like crazy these days. So good to have a break on a Sunday. Okay, so for the time, so what are we doing? This counter loops through each word, which is big O of n, like assuming they're the same length. So, I mean, I guess like worst case, one word is longer than the other, so we can just say like max length of, S, S and goal, where these are the 2 lengths, something like that. Whichever one's longer is going to be longer. So if the lengths aren't the same, we're going to return false. Now, this left and right is just looping through each one. So this is big O of n and big O of n. Okay, this is just looping through one of the strings. That's big O of n. And then this max values is going to loop through all the values. This is 26 maximum. And then this is nothing. So it's just going to be this is going to be our time maximum of SM goal for our space. So like I said, you can argue that these counters are actually big O of 1 because, we're going to have a hash map of every single letter in the string along with its count, but it can only have 26 keys. And so if we have one with 26 keys and another 26 keys, this never gets bigger with input, right? So if this input's like 5,000 or whatever, these never actually grow with the input. So you could argue that this is big O of 1. Okay, and that's going to be it. And I think, we don't have any other variables in here, right? Yeah, we don't have any other variables. So that is going to be it for this problem, and hopefully you liked it. And if you did, please like the video and subscribe to the channel. We've actually gotten past 200 subscribers today, so thank you guys for that, and thanks for watching. I'll see you in the next one.